Hello, and hope you're doing well. My name is Alex, and I'm a challenge developer for the President's Cup Cyber Competition. The challenge I have for you today is from President's Cup Season 6 Teams Finals. This challenge is a combination of technical forensics and penetration testing coupled with intelligence analysis to create a symphony of skill sets being assessed called Ransomware Rhapsody. In this challenge, you are cast as a senior member of the Rapid Response Team, the RRT, for a corporate entity breached by a syndicate called The Wanted. They've breached global networks of varying sizes and of call signs which are categorized in the intel that's provided to you at the start of your challenge. After initial triage, your team was able to isolate the first infected asset, and it's up to you to conduct a full forensics investigation on the asset, unlocking its secrets and finding out that this is actually a recruiting tool for the syndicate. So without further ado, let's get into it. During discovery phase operations, we're going to want to look for all non-standard files owned by a specific user and determine what we're up against. After running this command, we find a weird set of artifacts. It looks like there's the existence of a zip file called we want you. Looks like in the temp folder, there's a malicious service that currently exists that doesn't completely match the template of the others in terms of file structure. Finally, we see a bunch of .wntd files. These files, by extension, match the information presented to us in the intel. Running the following command will reveal a hidden directory in our own home directory. The first question asks what the name of the directory is. In this case, we found that the answer is this folder. Not too shabby. The first artifact that'll lead us to success involves the initial banner that we saw when we were first logging into this machine. It states, "We are the wanted. Let's play a game, shall we?" According to the intel, the syndicate uses leet speak and puts payloads and other useful information in plain sight to mock their victims. And in this case, we'll be using the specific phrase to get us the information that we need from the zip file. In this next minute, we'll be quickly walking through scripts that you've seen in the context of the solution guide. We're building our word list to then use with the final script. In the solution guide, we provided you a Python script that can be used to brute force the zip file. The algorithm was designed to go through every permutation of the sentence and also chop it up in a way that could lead to passwords such as we or we are the wanted, for example. We've now run the script, and once unzipped, there does lie another trick ahead. As you can see on the output, there is a hidden cache file. You'll have to navigate to temp/.cache. From within there, you will find the wanted.txt file. This will actually provide you with the byte version of the AES key. Using Python and its bin ASCII or cryptography libraries, you're able to transmute this byte level data into a hex value, which we'll use later on to decrypt the encrypted files. Backtracking to the malicious service folder that we found in the temp file, we find a singular file which has the same title as the folder containing all the encrypted files we previously discovered in our first command use. When executed, this is actually a decryptor. This decryptor was left by mistake, but we can use this to our advantage. In looking at the encrypted files within the ransomware directory, we find that the length of the files are actually that of the minimum that is needed for a valid IV using AES CBC ciphers. This ended up being the IV. When run, is looking for input in regards to where the encrypted files lie, the AES IV, and AES key, and where you would like the decrypted files to go upon success. Given that we have the encrypted file location, the AES IV, and the AES key in hex form, we can now answer question number 2. Now for question 3. We will stumble upon one file that has what appears to be a password or key we can use for the associated byte data above it. This file is unique to the other ones, so we should take a deeper dive. Off screen, running some entropy tests gives me the feeling that the text above, especially in this file, may be XORed. And with that, we might as well create a script to XOR the discovered key against the whole file and see where we land. After running the script that's also present in the solution guide, we find a username and password hidden amongst the fray. To answer question 3, we need the password to the Ubuntu service, and it can be seen here. Next, exit out of this specific session and SSH into the same machine using the Ubuntu service. Upon successful login, the prompt changes into a phone, and upon going to the desktop, we find a callmon binary and a README file. Regarding the README file, we are told that Unity is key effectively. Interacting with the callmon binary asks for a key. As everything is in plain sight, the key must be all of the tokens you've received thus far, tied together in unison. We can flip the orders around to get different results, but upon a successful submission, we start to see a call initiated back actually to the syndicate. After the call is ended from their fearless leader Chase, we find a final token which you can submit to complete this challenge. Quite the whirlwind, but a true test of multiple disciplines. Thank you for watching, and hope to see you in the next competition.